Hey folks, thought I would do a couple of the homework problems here in section 8.5, the partial fraction section. This one you're asked to integrate 6x squared over x to the fourth minus 5x squared plus 4 dx. And well, let's get started. Remember, to get started you want to completely factor the denominator. So when I look at that denominator, x to the fourth minus 5x squared plus 4, I think it factors to an x squared minus 4 times x squared minus 1. But notice each of those factors in turn will factor. So let me continue to factor. So x squared minus 4, that factors to x plus 2 times x minus 2. And x squared minus 1, it factors to x plus 1 times x minus 1. Okay, so I have it completely factored. So let me set it up to go through the process of partial fraction decomposition. So remember, we have a 6x squared over x plus 2 times x minus 2 times x plus 1 times x minus 1. And remember, I have to set up a fraction for each one of those distinct linear factors. So that gives me an a over x plus 2 plus a b over x minus 2 plus c over x plus 1 plus a d over x minus 1. Okay, so next, multiply both sides of the equation by the LCD. So that gives me a 6x squared equals a times x minus 2 times x plus 1 times x minus 1 plus, okay, when this term gets multiplied by the LCD, I have b times x plus 2 times x plus 1 times x minus 1. When this term gets multiplied by the LCD, I'm left with a c times x plus 2 times x minus 2 times x minus 1. And well, hopefully I have enough room for when this term gets multiplied by the LCD, we get a d times x plus 2 times x minus 2 times an x plus 1. Just enough room to fit it on the board. So let's see. Strategic values. Going to pick some strategic values. So if I pick an x value of 2, so if I pick x equals 2, over here I get a 24, and see, that would be 0, 0, 0. So that will give me 4 times 3 times 1, so that's a 12. So I get 24 equals 12b, or b is equal to 2. Okay, so next up I would probably pick my next strategic value. I'd probably pick x as negative 1. So x is negative 1. And let's see, over here I get a 6. So if x is negative 1, okay, this is gone, and this is gone, that's gone, so I get, let's see, I put negative 1 in for those x's, and I get, is that 6? So a 6c, so that tells me c is equal to 1. And I'm going to have to move over here. The next strategic value I would pick is x equals 1. So if I pick x equals 1, so that would give me a 6 equals, okay, so this is gone, this is gone, this is gone, 3, 1, 2. So I get 6 is equal to 6d, sorry, negative 6d, because there's a negative 1. So we have d is negative 1. And then finally, the last strategic value for x. Let's see, I've done 2, -1, 1. Oh, -2. So we do x is -2. So -2 comes in for the x. Over here I get a 24. 24. Let's see, that's gone, that's gone, that's gone. So let's see, -2 comes in here for x. And I get, -12. So -12a. So that tells me a is -2. A lot of algebra. That's basically all it is a lot of algebra. So let's see, I've determined a is -2, b is 2, c is 1, and d is -1. So I have these values, a, b, c, and d. So, I'm going to have to do a little erasing here, run out of room. So let me, I'll just keep this here. So let me erase this. So hopefully you have written down how we did that. And with those values that we determined for a, b, and c, I've turned the original integral into integrating. See what we had a is -2, so -2 over x plus 2. We said b was 2, so that's 2 over x minus 2. We came up with c as being 1, so that's 1 over x plus 1. And we came up with d is -1, so this is -1 over x minus 1. And now the calculus part, the calculus part's actually kind of trivial. We get -2 natural log absolute value of x plus 2 plus 2 natural log absolute value of x minus 2 plus the natural log absolute value of x plus 1 minus the natural log absolute value of x minus 1. And shouldn't forget to tack on a plus c. I'm sure the back of the book has used properties of exponents to maybe combine or collapse all that down into a single logarithm statement, stuff in like a fraction, product in the numerator, product in the denominator. I'll let you see how to simplify it down. But that's all there is to integrating that one.